This is a follow-up video that's going to demonstrate the installation of a new driving dog on a Lester wheel for 1974 R90/6 with about 90,000 miles on it. In the prior video I explained that I had purchased some hardware years ago in preparation for this job, and that hardware consisted of the AN4-11A bolt with its associated AN363-428 nut and a couple of washers. I believe that hardware will work on the OEM hubs, but you can see that the grip on the AN4 bolt is quite a bit longer than the bolt I'm going to use on my Lester wheel, which is an MS21250-04008. I'm going to use this 12-point grip bolt, and it has a 1/2 inch grip here, which is just about dead on for the clearance, the distance it has to penetrate the wheel hub, and then also through the flange of the hub. So the grip, so no threads will be present in the through holes on the driving cog, nor in the hub itself. And I'm also using a low profile MS21042-4 nut, which is much smaller. It's lower in profile and it's smaller than in outside diameter than the original nut I was considering. This way I can get a 5/16 12-point socket on either end, either the nut end or the bolt end, to apply the torque to tighten it down. I did have to use a Dremel tool very carefully to grind flats into the driving dog so that the nut will lay flat on the flange. So that'll lay nice and flat, and I'll have no trouble getting the bolt threaded through there. And I can get a socket on that as well without issue. So that'll fit nicely. And allow me to tighten the nut, allowing the bolt to remain fixed. There is a radius. This is a flanged head 12-point bolt, and there is a radius. I don't know if the video is going to pick it up there, but there is a radius there. So I will have to put a chamfer on the hub side so that sits flat against the hub. The bolt and the nut are both flanged, so I'm not using washers, and if I did use washers, then it would disturb my grip length, actually it wouldn't disturb the grip length. It wouldn't affect that unless I used it under the bolt head. If I used a nut or a washer under the nut, it wouldn't affect this grip length at all in relation to the hub and the driving dog. So I'm not planning on using washers though, but they're both flanged and unneeded in this case. In the OEM configuration, 2 washers are needed in order to reduce this grip length appropriately, so you have sufficient threads showing to tighten the nut, but have no threads in the bore area, the bore of the hub, or in the flange through holes. This driving dog I bought from BMW, and the old driving dog that came on the Lester wheel is of a different material. I was easily able to take a file and create a flat using a hand file on this driving dog. It cut easily with a file. I tried a file on the BMW driving dog and I couldn't even scratch the surface. So the BMW driving dog is much harder than the driving dog or the material they used to make the driving dog on the Lester wheels. So now we'll move over to the wheel and actually install the new driving dog using the MS bolt and its associated lock nut. Okay, we're over at the wheel now, and I've got the left side of the wheel facing up. So the bolts I'm going to install from the left side. However, as previously mentioned, these bolts have a radius where the flange meets the grip, and therefore it won't sit flat in the hub. So I'm going to have to chamfer, as I've already done on this one, I'm going to have to chamfer the holes to ensure that the bolt head sits flat against the hub, as this one now does, but the others will not. So that's sitting flat, and I'm going to go ahead and chamfer the other holes, and then we'll go ahead and install the flange. Also, previously I did very carefully take a Dremel tool and created a flat, took out a little bit of material to create a flat so that there was no interference between the bolt head and this radius in here. So I did have to take off some material in order for the bolt head not to sit up against that radius. It's very easily done with a Dremel and a grindstone. It came out very easily. So I'm going to go ahead and create the or chamfer these holes, and to do that I'm just using a standard chamfer drill bit, and I'm going to use low RPMs and go ahead and just kind of ream that the surface of that the openings. Okay, now I'll go around and inspect those and ensure that I'll put a bolt in each one and ensure that the bolt sits flat against the hub, so that I don't have any problems with that bolt head. Good. That's good. I'll be a little bit more. Okay, I'm just going to clean up a couple of them, but for the most part it's looking pretty good. Okay, I went ahead and dressed the chamfers a little bit more, so the bolt heads have sit nice and flat now against the hub. So the next step now is going to be to install the hub, or excuse me, the driving dog. Now, the bolts slip fit through the hub, but they're a press fit, a resistance fit into the drive dog. So I'm going to have to tap them through. I'm going to put 2 bolts in, get the nuts on, and draw the hub down, or the driving dog down to the hub. And then I'll install the rest of the bolts. So there's 2 of the bolts coming through. I'm going to go ahead and get the nuts started and actually run them down and cinch them up. Now I need to ensure that I have threads coming all the way through the drive dog, but no threads in the bore of the hub or in the bore of the drive dog. I'm going to torque these down to I think about 110 inch-pounds. Okay, so the hub is not sitting flat against the, or the driving dog is not sitting flat against the hub, so this side hasn't pulled down completely. I'm going to remedy that right now. Okay. The driving dog is now sitting flat against the hub, so I'll go ahead and snug these up a little bit more. Good. Okay, so I'll install the remaining bolts. So I'll install the remaining bolts and tighten them down. All the bolts are in and torqued to actually 115 inch-pounds. What's critical about this job is ensuring that the bolts are driven all the way in and seated on the outside of the hub, and at the same time the flange is fully seated on the inside to the hub. I probably spent 30 minutes or more torquing these down, and I would have to tap the bolt from the outside, seat it, tighten, and incrementally go around to draw this down so that it's absolutely seated against the hub, so that the driving dog is seated against the hub, and that the bolts are seated against the hub as well. And it'll fool you. You got to keep torquing and retorquing until you're sure that you've got every one of those bolts completely seated and a true torque on each of the bolts. That's the critical thing in this job. It's easy, it'll fool you, and I went ahead and measured counted the number of threads above the nut, and I've got the equal number of threads above each nut. So I'm going to go back and retorque this again later, just to ensure that I don't have any stretching or further seating going on here while it's under tension. So I'm going to do it yet again one more time later on, and then I'm going to use a Dremel and a cut-off blade to cut these excessive threads off. Okay, I retorqued the flange yet again, and everything seems good there. So I'm going to go ahead and Dremel off these bolts. I'm going to start with a very small used cutting blade, and then I'll finish it off with a fresh blade. I don't want to overheat the bolt, so I'm going to do this very slowly. Just about off. My blade isn't long enough, but it's ready to fall off. And I'm just going to leave that just like it is. So I'll go ahead and do the rest of them. Well, I finished cutting off the excess threads, and I'm going to call the job done. Of course, the test will be in the riding, running it, and see how it holds up over time. The final outcome doesn't look too bad. Looks a little busy in there now, but so far turned out okay.